Hello, room 13. It's Miss Martinez again. I hope everyone's being safe and healthy in their homes. So today I'm here again to talk about another very cool math lesson. Let's get started. Today we're going to be talking about lesson 6, and our objective today is decompose fractions using area models to show equivalence. So it looks like we're still working with decomposing fractions using area models. Let's take a look at our first problem set. Let's go ahead and read the instructions. It says, each rectangle represents 1. Draw horizontal lines to decompose each rectangle into the fractional units. As indicated, show the model to give the shaded area as sum and as a product of unit fractions. Use parentheses to show the relationship between the number sentences. The first one has been partially done for you. So if you could see, I've highlighted these two words, sum and product. Where have we heard sum before? Let's think about that. Well, I know sum refers to when we're adding, right? And product, I think, yes, it means when we are multiplying, right? When we multiply numbers, we get a product. When we add numbers, we get a sum. So just keep that in mind. So the first thing I see here in A is I see my model, my area model, and like I always say, let's pretend this horizontal line is not here, just for now. If the horizontal line isn't there, my whole would be in thirds, right? Agree or disagree? And the shaded part of my thirds looks like would be 2. And they already wrote it for us here, and they already wrote it for us here, right? If you see these little brackets, remember I told you, think about them as little arms that are hugging the area model, and that will show you the part that we're focusing on. So 2/3, and after we decompose the fraction, and I'm going to go ahead and use my purple marker for this. After I decompose my fraction, I no longer have thirds, right? It looks like I made, let's see, 1, 2, 3, 4, 5, 6, right? Oh, yep, and they already gave me that too. But now, how many parts of my 6 are shaded? It looks like 4, right? 4/6. And I'm going to go ahead and fill that in here. 4/6 are shaded. Now here, it looks like a lot of work, right? But after I explain it to you, it will make a lot more sense. So don't worry about it. Let's look at 2/3. If I were to decompose this 2/3, and I'll do this to show you. Well, I know I can decompose 2/3 by just saying 1/3 plus 1/3, right? Agree or disagree? And now this looks like we're decomposing the 4/6. So go ahead and draw this to help us visualize it, right? So we know that 4/6, we can write it down as 1/6 plus 1/6, and we'll group these two together by adding the parentheses, right? So if we have 1/6 plus 1/6, we'll group them with the parentheses. And then if we add another group of 1/6 plus 1/6, and I'll add the parentheses, I know that will equal to, you guessed it, 4/6. Agree or disagree? And now here, they're telling me that this part, the 4/6 we decomposed here, they just moved it down here. Draw a little arrow here. That's all they did. is move it down here. So they're saying that 1/6 plus 1/6 plus 1/6 plus 1/6, isn't that the same thing as 2 times 1/6? Well, I'm going to go ahead and highlight this group here. 1/6, but that's 2, right? That's 2. And I'm multiplying by 1/6. And it looks like I have another group right here. I'm going to go ahead and, isn't that 2 also? And I'm multiplying by 1/6, right? Equals to 4/6. Now, even further, I could say that 2/3 is equivalent to 4 times, oh, wait a minute, Miss Martinez. Where did that 4 come from? Well, if we were to even take a closer look, you see this 2 here and these 2 here? Can't we just say that, add them and say that's 4? Because I decomposed the 1/6. 1, 2, 3, 4. 4 times. So I can also say 4 times 1/6. Agree or disagree? Equals to 4/6. What do we think? We good? Let's go ahead and do B. I think we should do B just to get a little more practice. Now, if I look at B, first thing I'm going to do is I'm going to go ahead and just work with my area model before I decompose it first. That's going to be my first step. So let's go ahead. What's my whole here? Let's see. 1, 2, 3, 4, 5. Okay. Go ahead and write that. And how much is shaded out of my fifths? It looks like 1, 2. 2/5, right? I'll go ahead and write that here too. Now, if I look at this, they're telling me after I decompose my fraction, this is the whole I should have, right? So I know that if I have 2/5, and I'm going to go ahead and use my marker. And if I decompose my fraction, now, did I make tenths? Did I follow the instructions? Do I have tenths now? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I sure did. So now, looks like I have tenths, right? And how much of the shaded is, how much of this is shaded now, now that I have tenths? Let's see. 1, 2, 3, 4. 4 tenths. What do we think? Well, I'm going to tell you something. I know we did this, but I'm going to go ahead and I'm going to make things a little bit easier for us because I feel like all our friends can do this. So why don't we go ahead and let's just worry about decomposing this fraction. So we can go ahead and bring this down. We could just say 2/5. And let's decompose our 4 tenths. Can't I just, can't I say, I have 4 tenths here. Now let me think about it. Okay, can I say 1/10 plus 1/10? 1/10 plus 1/10. That's my first group. And I'm going to add a parentheses. Plus 1/10 another one here, plus, yes, 1/10. And I'm gonna add a parentheses here to this group. Isn't that 4/10? Agree or disagree? So now I can say that 2/5 is equal to, well, they want us to multiply, right? Well, how many times did I decompose the 4/10? Let's see, 1, 2, 3, 4. 1, 2, 3, 4. 4 times. So can't I just say 2/5 equals 4 times 1/10 equals, is equivalent to 4/10? Agree or disagree? I think room 13 is ready. Okay, go ahead and continue and do the rest on your own. I'm gonna go ahead and jump to number 2 because I thought it would be great to practice number 2 together. Let's read number 2. It says, draw area models to show the decompositions represented by the number sentences below. Express each as a sum and product of unit fractions. Use parentheses to show the relationship between the number sentences. Okay, got it. So it looks like here we have the equivalent fractions, but now we have to create our area model, right? Okay, so the first thing I'm going to do is I'm going to start with this fraction, and I know that my whole is going to have, let's see, is it going to have 5 parts? I think it is, right? So I'm going to go ahead and I'm going to write do my area model, and I'm gonna do how many? 5, right? 1, 2, 3. 1, 2, 3. I'm gonna add more. Miss Martinez isn't a great artist, but I should have made it a little bigger. 1, 2, 3, 4, 5. Looks good. How many parts should I shade? Should I shade 3? Sure, let's go ahead and shade 3. 1, 2, 3. Do I have 3/5? I sure do. Now, I'm going to decompose my fraction. And I know that after I decompose it, I am no longer going to have 5ths, right? And I can go ahead and actually write that here if I want. No longer going to have 5ths, right? What am I going to have now? It looks like I'm going to have 10ths. So I'm going to go ahead and decompose my fraction. Did Miss Martinez make 10ths now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like I did, right? So after I decomposed it, I don't have 5ths anymore, I have 10ths. And how many parts of my 10ths are shaded now? Looks like I have 6. What do we think? Is Miss Martinez doing okay? So I can write it here too. I know that 3/5 is equal to 6/10. Yes? Good? Okay. So remember I said let's just worry about decomposing this number, right? So I'm going to come up down and I'm going to bring my 3/5 down. And I'll just worry about decomposing this one. Well, let's see. How am I going to decompose this? Interesting. Well, let's see. I see 1/10 here and another 1/10 there. Can I group these two together? Sure, let's do that. So I'll say 1/10 plus 1/10. And I'll separate this little group by adding parentheses. Then I'll add, can I add this 1/10 plus this 10th? Isn't this another group? Sure. 1/10 plus 1/10. And I'll separate it using my parentheses. And I'm done. I have 4/10. Oh, wait a minute. No, Miss Martinez. It's not 4/10. It's 6/10. I only have 4/10 now, but I have to decompose 6/10. Oh, yes, you're right. Well, I guess I could add these two, right? Of course. So I'm going to add 1/10 plus another 1/10. And I'll add my parentheses to separate those. Just to group them, to make them easier to read. After I did that, I know that 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. We know that it is 6. Yep, you guessed it, tenths. Now, Miss Martinez, now what? Well, now I could say 3/5 is equal to how many times did Miss Martinez decompose those 6/10? Let's see. 1, 2, 3, 4, 5, 6. So I can say 3/5 is equal to 6 times 1/10. And that's going to be equivalent to, it's going to equal 6/10. What do we think? Agree or disagree? I think you'll be doing great. Thank you, Room 13. Take care.